minimize. Okay, two binomials. So when you have a binomial or a trinomial or a polynomial, I don't know, 6x cubed, we have brackets here. So if we got two binomials, there's going to be two sets of brackets. Okay? So first, a couple of algebra tiles. I think we're kind of getting the hang of this stuff. Okay? What does this mean? Okay, it's not just draw the picture. This is on one of these sides, okay, and the other one's on one of the other sides. I did that correctly. Okay, because this is a x1, that's a 1, that's a 1. So this is x plus 3. Think of it as a dimension. Think of it as the length or the width, either or, it doesn't matter. X plus 2. There's x plus 1 plus 1 plus 2. Think of that as like the width times the length. What's the area? The other word they have is product. Well, you know when you multiply something, the answer is called a product. Okay? But let's not overthink it. We're going to tell you how to do this the big kid way in a sec. Can we fill this in? What makes it look, well, what looks like it fits here? These lines got to line up. Okay? So that's what looks like it fits there. Okay? And what's this thing called? It's an x squared. Positive times a positive. This thing's also positive. Let's quickly shade it. Okay? Shaded is positive in this book. Okay? If it's hollow, it's negative. And that's opposite as to what you're going to have in the government exam. But let's not worry about that today. What looks like it fits in this space? I got a long thing here. I got a short thing there. Looks like one of those. And sure enough, what is x times 1? It's x. Positive, positive. This is the same thing, so I should have the same shape. Same thing, same shape. X, positive, X, positive. Okay, that's the top row. I have two more rows here. What looks like it's going to fit here? I got a long piece here. Got a short piece there. That looks like an X. Positive, positive, it's all positive. Let's just go down there, because that looks like the same thing. Okay? Nice and neat, nice and neat. What looks like it's going to fit here? What's the length of this side? What's the length of this side? And what's 1 times 1? It's 1. Positive. Same thing, same thing. Make it reasonably neat, but don't take all day. But if you start, like some of you guys are doing like this kind of thing, okay, and that's pretty ugly. All right? It should make a nice rectangle when you're done. Okay? Here's my aisles, here's my hallways. I can walk down the hallways, right? It looks like it all kind of fits here. Nice and neat. What's the product? All you got to do is look and see what you have. I have an x squared. I have 1, 2, 3, 4, 5 x's. Get that one nicer. And I got, sorry, I didn't shade these in. These are all positive. How many singles do I have? 1, 2, 3, 4, 5, 6. Okay? So this is x squared and 5x and 6. Who knew that looking at this binomial times this binomial? Probably nobody. Okay? Because I haven't taught you how to do this yet. Okay? So you can still get it this way. Now, what's the difference here? We're not told what's what. What do you want in this bracket? You want the one on the top or the one on the side? It doesn't matter. What is this? That's an x and a 1, otherwise known as 2x plus 1. That's the length. Let's call this the width. The width is x, 1 and 1 and 1 and 1. That's x and 4. What happens when I multiply these two binomials? Well, we can find out with algebra tiles. Okay, so I'll go a little quicker here. That looks like it fits there. That looks like it fits there. Ditto, ditto, ditto. Are these all positive? Positive times positive, 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 positive. Okay? This isn't art. Let's not take all day. Let's just make it neat enough so we know we got the correct answer. Okay? Looks like a nice rectangle. Positive, 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 positive. What looks like it fits down here? Looks like another x, positive. 1 times 1. That looks like it fits. That looks like it fits. Keep all your aisles open, right? Keep all your hallways open. Hallways clear. Don't want a fire hazard. What's the product? 2x squared. How many x's? 4, 8, 9 x's, and, whoops, shade, 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 1, 2, 3, 4. Okay? There's the product. There's the area. Think of it as area. Length times width, if that's a shoebox, okay, and I just want like the surface area of the top of the shoebox, don't think volume, that's what it is. Okay, maybe Nike has done this. Let X be 1.67. That exactly holds this type of shoe. Okay, got a basketball player, size 14. Well, now X is not 1.67, it's 2.38. That's the exact same box that'll hold that shoe. I don't want it any bigger because that costs me more in shipping when I send it from China. Okay, the whole world's made in China. You guys know that, right? Okay. All right. I was just talking this the other day. Tetra Paks, you know what I'm talking about? Your juice boxes. When I was a kid, we didn't have these. It either came in cans, they're all cylinders, or they came in bottles. Think about shipping a case of bottles. How much air is in that box? That's a lot of wasted space. You can only fit so much on a ship, right? In a truck. Tetra Paks, how much volume is wasted? None. Like an ant couldn't even squeeze his way in that box. You know the guy who invented Tetra Pak? He's Swedish. Every time someone drinks a juice box, he gets like, I don't know, I'm guessing, 1/5 of 1 penny. Okay? Multi-100 millionaire. Just from one little idea. Let's eliminate some space when we ship stuff. Anyway, I got off track a bit. Let's just look at one with a negative. Okay? What's the dimension here? That's a positive x. That's a negative 1. That's a negative 1. So that's x minus 2. Here I have x minus 1 minus 2 minus 3. What's the product? What's the area in x? Okay, well, that's the only variable we have. This we've done before. Positive times a positive, that's positive. Okay? But now we got some negatives. What's a positive times a negative? Negative. Don't shade it. Ditto. Same thing. Ditto. Same thing. Let's go down here. Positive times a negative is a negative. Don't shade it. Let's go down here because it's the same thing. Negative 1 times negative 1. That one I want to shade. Same thing. Same thing. Am I making a nice rectangle? Looks like it's complete. Not quite. Space looks good, but double check, right? And sometimes you're going to make a mistake. That's why we want to use pencil. Some of you guys are using pen. If you make a mistake, how are you going to undo that and make it so that it works? Okay? Double check it. Positive times positive. Yep, that's positive. These are all negative times positive. Negative times positive. Those are negative. Negative times a negative. Positives. Okay? What's my product? I have a positive x squared. I have a negative 1, 2, 3, 4, negative 5 x's. And positive 6. Okay? Are we all algebra tiled out? I will not show you this in grade 11. It's part of the curriculum in grade 8, 9, 10, probably. Anybody do this in elementary? Algebra tiles? No? No teachers have them? Wow. They're hard to come by and chase. It's like contraband, right? Okay, that's one way to multiply a binomial times a binomial. It's usually not everyone's favorite way, but you can do it that way. I'm going to show you 3 more ways to do it. Okay? These are the ways you probably want to do them. So, in one example, we used algebra tiles to multiply that by that. We found that the product was this. Okay? In short, this is what we did, but without the pictures. Okay? On one, it was x plus 2. On the other one, it was x plus 3. We don't really have to draw the picture. This is called an area diagram. What's x times x? Yeah, what's 3 times x? X times 2, 2x. 3 times 2 is 6. Add them all up. X squared and 3x and 2x, that's 5x and 6. There's the answer. Okay? So it's a little quicker, isn't it? Okay? Visually, it's not as appealing, not as colorful, but we can do an area diagram. You get the same thing. So it doesn't matter which one you write where. I have 2x and a 1, and on this side I have a 5x and a minus 6. If you like the grid, let me do a different color. Do the grid. How many boxes do I have to fill there? 4 boxes. Okay? 2x times 5x is 10x squared, right? Same base, add the exponents. 1 and 1 is 2. 1 times 5x is 5x. This box down here is 2x times negative 6 is minus 12x, and negative 6 times 1 is negative 6. Did I fill all 4 boxes? How many terms do I have there? You will always get 4 terms when you multiply a binomial times a binomial. It'll simplify. I can collect these, right? So I have 10x squared. What's minus 12x plus 5x? Minus 7x minus 6. Okay? So it becomes a trinomial when you simplify it. But when you multiply a binomial times a binomial, think to yourself, I should always have 4 terms. Here visually we can see that, but I'll show you another way. That's the most popular way, where if you don't remember that, you might make a mistake. Okay? Oh, this looks nasty. Okay? How would I put a squared in an algebra tile? Don't do this, but like, do I want to do that? Yeah, that's where the model kind of like stops. It's too big and ugly. But with one of these, I got a squared, I got a minus 8. I have an a squared, I have a minus 5. Okay, I can do that. You don't have to do the grid. Let's do that one without the grid. You got to remember though, there's 4 spots here I need to fill. What's a squared times a squared, Alicia? Sorry? Power 4, a4. Okay? Add the exponents. You're multiplying with the same base. Negative 8 times a squared minus 8a squared. A squared times negative 5 minus 5a squared. It's not wrong to say this. Okay? That's the same as this, but this is how we want to write it, right? Because do you want the coefficient after the variable? No. And if you don't put the brackets, that's wrong, because it would be a squared minus 5, right? Okay, so that's how you want to write this, right? Always the number first. Negative 8 times negative 5 is positive 40. Okay, add them up. That's a4. Let's just write this out in 2 steps. Minus a8 squared minus 5a squared plus 40. I can collect these like terms, right? A squareds are deer in headlights. I got negative 8 deer in headlight, minus 5 deer in headlight. How many deer in headlights do I have? Minus 13 deer in headlights. Okay? So it doesn't say simplify, but we want to do that. Anytime you can collect like terms, it's understood that's what we want to do. Okay? If you feel like reading that, feel free, but anytime you're multiplying a 2-digit number, you can use the same strategy, and then you can do it in your head. Okay, I'm not going to teach that, but it's kind of cool trick. Okay, we've looked at algebra tiles, we looked at area diagram. This is another way to do it. Remember distributive property from yesterday? If I'm multiplying that by, A and B, everything outside the brackets is multiplied by everything in the brackets. But now, I have two things outside the brackets. Not just one thing. It's not a monomial, it's a binomial. So all you got to do is do the same thing twice. Okay, this is multiplied by everything in the brackets. So I got A times C plus D. And then you got to go back and go, I got to do the other one. B is times everything in the brackets. Okay. B times C plus D. Okay? If you just look at the red one, what do you have? AC plus AD. Okay? If I just look at the green one, I have BC times BD. How many terms should I have when I multiply two binomials? After you simplify, you could have 3, but you always get 4 to start. Okay? Here I got 2 terms. Well, now I have twice as many because I have a binomial, not a monomial. Okay? So distributive property, you can do it this way. You probably don't want to. Most kids don't like to, but it'll ask you in the assignments to do it like this. Okay? So just to let you know, I know you're looking at this, some you're going, what, huh? Okay? This is a nice way to do it, and the last way I'll do it is after this. It's called FOIL. Okay, so I'll just show you a couple of these. Take the first one, multiply it by everything in the second set of brackets. And then I take the second one plus 3, multiply it by everything in the second set of brackets. And you had a couple questions like this yesterday, didn't you? It's just distributive law twice, once you do that first step. Okay? So this is x squared plus 2x plus 3x plus 6. Do I have my 4 terms? Can I collect a couple of them? Yeah, 2x and 3x is 6x. Okay, it simplifies to a trinomial, but you should look for your 4 terms. Okay? Just do one more. Let's do C. Take the first one, multiply it by everything in the second set of brackets. Take the second one, minus 8, multiply it by everything in the second set of brackets. That's not a 9, that's a Q. Let's do this so we're not confused. Okay? So I got PQ. P times negative 8 is minus 8P. Negative 8 times Q is minus 8Q. And negative 8 times negative 8 is positive 64. Can I simplify anything in this one? Are there any like terms here, Calvin? Covered all bases, gave me all choices. PQ is not the same as P's, or just Q's, or just a constant. All four of these terms are different. So here we're not simplifying. Can't do anything with these. They're all unlike terms. Okay? So that's an option, but like I say, most kids, nah, that one's too hard to follow. A couple of them from time to time, right? We're all individuals. I'm giving you 4 ways to do this. I don't care which way you do it on a test. Use whatever method you're going to like. That's why the assignment's going to ask you to do all 4 ways. You're going to find, okay, most kids like to do it either FOIL or with the diagram. A couple of kids, algebra tiles, hey, I like that. A couple of kids, this one I just did, distributive law, I like that. That's fine. Okay, lots of ways to do this. Here's the most popular way, and if you get to grade 11, this is the kind of way that I will do it, because I can't teach every question 4 times, right? I can't do it 4 different ways. This is kind of our bread and butter. This is an acronym, we know what that is, right? Okay, it's a way to remember what to do. So, watch this. FOIL. F is first terms in the brackets. This is the first term. That's the first term. So those are the first terms. I'm going to multiply those together. X times x is x squared. Okay? Oh, the outside terms. This is, not the outside. This is on the outside, and 4 is on the outside, right? The far left and the far rights are on the outsides. Does that make sense? What is 4? Those are outside. 4 times x is 4x. Let's go. How about orange? Okay, I, inside terms. If those were on the outside, what are on the inside? 6 and x. Okay? I, inside. Okay, what's 6 times x? 6x. Last one, L for last. Well, last terms in the brackets. This is the last term in this bracket, and this is the last term in this bracket. What's 6 times 4? 24. That might look hard to follow, but given a couple of examples, a couple of practice questions, you're probably going to like that way best. But hey, like I said, it doesn't matter which way. Do I have my 4 terms? Okay. Can I collect a couple? Yes. 4 and 6 is 10 x's. Okay. So let's look at a couple more. I'm not going to write the F-O-I-L. I didn't write the L's, darn it. Okay, so L, there's L. Okay, so let's just do it like this. First, the first things in the brackets are the y's. Okay, multiply them. What's y times y? Y squared. Let's write it like this. Okay, that's F, done. Outside terms, that's y times 2, which is 2y. Inside, negative 7 times y, which is minus 7y. And then last, negative 7 times positive 2 is minus 14. Okay? Any questions on that? Can I collect a couple? First of all, do I have 4 terms? Yes, I do. Negative 2 minus 7 is minus 5. Don't worry, I'll do the other 2. Okay, if you think you got it, go ahead. If not, watch another. First, 3x times x is 3x squared. Outside, negative 5 times 3x is minus 15x. Inside, 1 times x is 1x. And last is 1 times negative 5 minus 5. Okay, minus 15 plus 1 is minus 14. Still have that. Still have this. In a way, yeah, but it's a different thinking, right? You get the same answer. I don't care which way you do it. FOIL, distributive law, algebra tiles, area diagram, we all better get the same answer, okay? But this is just a way to remember it. All you need, I mean, do you have to do FOIL? No. You can LOIF. I don't want to confuse you. It doesn't matter what order you do it in. I could have done last first, first last, okay? I can OILF, okay? Like, is that helpful? Probably not. This is just a way to remember that you need, there's 1, 2, 3, 4 terms. The 4 different combinations multiplied together, okay? This is an important one because I guarantee you, one in every, look around at 5 people, one of you 5 will make a mistake doing this question. Okay? Is that a binomial times a binomial? Remember, like 3 squared, yeah, it's 9, but expand it out. What does that mean? It means 3 times 3. Okay? Don't do this and go, that's 6 squared times a squared minus 5 squared times b squared. That's not what this is. This is, the first step should be, write it out. This thing squared is this thing times itself. Okay? And even if you're one of the smart kids who got like 90-95% in this class, write it out. Because I even see those kids make a mistake. Maybe not this year, maybe in grade 11, but it's very common. Okay, that's a binomial times itself. Write it out. Okay? FOIL. 6a times 6a is 36a squared. Negative 5b times 6a is minus 30ab. Inside, hey, isn't that the same thing? 6a times negative 5b is minus 30ab. Last is negative times a negative is a positive. 5 times 5 is 25. B times b, b squared. Okay, can I collect a couple of things? If I would have wrote it like this, instead of having AB, I wrote BA. Can I still collect those? Yeah, because that says exactly the same thing, doesn't it? Okay, doesn't matter what order it in. I could have went like this. That's the same as this, right? So let's be consistent and write it the same. If that's an AB, let's write that as an AB. Those are the same. I got minus 30 minus 30, minus 60 ABs, 36a squareds, and 25 b squareds. Okay? So, like I said, the assignment will ask you to do it all different kinds of ways, right? So 1, just A, B, C. I know you guys love your algebra tiles and you want to go on to E and F and D. Okay, just A, B, C. 2, 4, 5, all of those A, C, E, G only. All of 6, Adam. And 7, just A, C, E, F. Okay?